Perfect. Well, as Brian said, I'm a former colleague of him, both from UKZN as well as CHPC. I'm now currently a bioinformatician and part-time HPC. Today, we currently have 40 nodes and growing fast. It's a great problem to have, but we're also onboarding a lot more users. We've got a lot more complicated system, and we basically need to make sure that users come with a basic set of skills to use the system effectively. And part of that is how do we teach them to make use of this system, and that involves transferring conceptual understanding as well as practical skills. So I'm going to talk a little bit today about challenges more that we're facing rather than solutions, and some ideas that I've had regarding them, but I'd love to hear more from the community. And my last comment there was sort of a bit off the cuff, but we've actually discovered that many of our users appear to be more knowledgeable than they actually are. And we think this is probably due to ChatGPT. So they're using the tools and we're happy about that, but at the same time, sometimes it's difficult to assess where they are in their understanding of basic concepts. Next slide. So this is just sort of a list of topics. We're going to talk about Bash command line basics, and I'd like to think about how to teach that as well as to assess it. Then looking at a conceptual overview of both HPC and HTC, I think it's important that users understand what they're doing and what the machine looks like. It gives them a better sense of what they're doing rather than using a black box. How to effectively use resources. This is a challenge we run into quite frequently. We have a fair amount of computational resources, and we ultimately want people to be able to do science as fast and as productively as possible. Part of that is installing software, so the approaches we use typically are environments and containers, but it's sometimes challenging to convey users how to best use these. We would like users to be able to do a bit of basic troubleshooting, so we're thinking about ways to teach this and to sort of transfer the ability to systematically troubleshoot problems on their own. And finally, if they do need to ask for help, we want to have them ask for a way which is productive, and I'll talk about what I mean by that in the end. Also looking at teaching modalities, methodologies, how we deliver this content so that it's most effective, we avoid information overload, and also trying to figure out if there are any allied efforts and curated resources there. So at the end of the day, we are not reinventing the wheel all the time. Next slide, please, Brian. So I'd like to come up with some approach to teaching the basic command line skills that's both interactive and allows us to get an assessment. The primary purpose is really to teach the concept from the ground up. Most of our users come to us with very little, if any, command line experience. But we'd also like a way to assess that the student has actually gone through this training and that they've kind of mastered the skills, at least to some level, before they jump into more advanced courses. We waste a lot of time. They just haven't got the foundation that they need, regardless of how we've tried to teach it or resource. I'd also like to approach this from more of a gamification approach. So kind of present it as a challenge rather than a test, because students often, or users often act more negatively if they feel that they're being scrutinized or tested rather than just giving them a way to show that they understand the work. It's also more of a static, a better way than presenting just static knowledge. This is through experimentation and kind of improve their troubleshooting mindset. We would like to have a better assessment of their skills, because regardless of what we request when we have follow-on courses, so dealing with science, either students underrate their ability or they overrate them. And as I said before, we waste a lot of time on things other than the material we're supposed to be teaching. And I also like the idea of sweat equity. So if people have to spend 30 minutes or 45 minutes to do something like this, they both learn the material, but they also show us that they're interested in whatever it is that we'll be offering. Next slide, please. So I take my inspiration from a lot of the cybersecurity challenges. As an example, I use Bandit from Over the Wire. And basically that's just a series of challenges where you log into your machine, you do the challenge, and then basically what you get at the end of that is a hash or a password to log into the next level. So it forces you to go through a sequential set of tasks, apply your knowledge, and to test it and to grow as a user. And it also, I think, it gives better engagement and therefore retention. When it's broken and they have to get assistance. Next slide, please. Also, we feel it's a good idea to give a conceptual overview of HPC, and sometimes we think a lot of our problems come from not having done this. In many cases, I think students users of our system have a very black box mentality. We'd rather that they understand why we want them to use a scheduler to submit jobs to compute nodes rather than trying to run things on the head node. We think this gains confidence and also allows them to much more effectively use the resources to ultimately get the science done, which is why they're here. Next slide. We also look at ways to use our resources more effectively, and there are a number of workflows specifically for bioinformatics, so SnakeMake, Nextflow, things like this, which allow students to obviously do reproducible science, but it also gives them the ability to effectively parallelize their jobs, so run many tasks in parallel, but without necessarily taking up large amounts of resources unnecessarily. So certain steps in the pipeline, for example, may not use as many resources as running multiple jobs in parallel at other stages. And it gives them a way to restart jobs that don't run to completion. Next slide, please. We also want to help users determine the appropriate requests. So many times they either request far too many resources, so far too much memory, or far too many cores, and we'd like to help them figure out what the appropriate amount is. So we teach them how to benchmark their codes, using a subset of the data. We also allow them to look at the historical data from completed jobs, and we'd like them to understand their specific jobs, so if their codes can use multiple threads, for example, and then also how to scale their jobs up so that they can ultimately complete their analysis as quickly as possible. Next slide, please. Another challenge is installing software, and we'd like to have users involved with this as much as possible. Of course, as a small team running an HPC, we do help users, especially when things are challenging, but ultimately, because there are a large number of packages of bioinformatics, it helps when users can do this themselves. So we teach them primarily how to use content Commander environments. We do teach them how to compile basic codes from scratch. I think that's probably going a bit over most of their heads. And we've started to use a lot of Singularity containers nowadays as a fairly easy way to get software to run on the system. And again, as a transportable way they can use and move that to other systems. And we really want to emphasize that these approaches enable and simplify the installation, they enhance reproducibility, and they do allow to move their workflows around other systems fairly easily. Particularly, Clemson has another campus-wide HPC system which they're able to access. Next slide, please. We're also trying to teach students how to troubleshoot. Some of them, as soon as they run into a problem, there's nothing more they can do, and they pass it across to us. We would like to teach them how to look at error messages and to figure out words and patterns that are important, develop systematic approaches to identifying the root cause, and how to find information about this and potentially solutions using things like Google without digging themselves down rabbit hole. Next slide, please. Also, how to ask for help, because this is a big problem we run into. And I only heard about the XY problem recently. I wish I known about it for a long time, but it's basically where someone asks for a solution to a problem that they believe is also what they're trying to do, but it's not the root problem itself. And in many cases, they're asking for something which is either not related, or they're looking at how to do something in a much more difficult way than necessary. We also want them to provide the appropriate information when they ask for help, so that we can actually get to the root of the problem as quickly as possible. Next slide, please. We, like many other people, have multiple teaching modalities. Again, some of this is out of necessity and some of this is out of convenience, but ultimately we'd like to find ways that increase engagements and also avoid information overload while transferring as much information as possible. Next slide, please. And finally, we don't want it to reinvent the wheel, so we ensure there are other sources of this information out there, and we would like to make as much use of that as possible, but at the moment we sometimes lack, I guess, the resources that we think are appropriate. So it's about collaborating with other people. We think ecosystems are probably in a much similar position, and we're ultimately interested in either collaboration or basically using publicly available materials. Next slide, please. And with that, I'd like to say thanks, and please join us on HPC Ecosystem Slack. I'm particularly interested in setting up that interactive tutorial where we can also do somewhat of an assessment when it comes to the basics of command line. Thank you.
Thanks, John. Can you hear me?